We are here in Liverpool today to launch the 2018 UK Robotics Week. This is just one of the 140 events this week, covering all different areas of robotics, going across the country. It is organized by the UK-RAS network, funded by the EPSRC. It consists of 28 universities across the country, bringing researchers in all areas of robotics, as well as business and also doctoral training centers, from surgery to manufacturing to deep sea exploration to space, to address the fundamental problems in robotics and autonomous systems.
Right, so this is my work. So I'm working in perception systems for the next generation of Mars rovers. So this allows us to do experiments with the next generation perception algorithms and how the follow-on missions, such as Mars Sample Fetch and Return, which should be happening sometime in the 2020s, will be able to travel faster and further and more autonomously across the surface of Mars. So this system is using the Akuyu 2D scanning LiDAR, and it's panning it across the scene to create a 3D point cloud of the environment. That gives you a really accurate, very long-range 3D perception of the environment. So it's much better than the stereo cameras that are used today. And then we combine it with the cameras which are already on this machine to actually produce a very accurate 3D texture-mapped colour image of the environment. This thing should be able to plan 100 metres at a time, create much safer routes and much longer routes, and be able to overall travel much faster across the surface.
So here we have a soft prosthetic hand that is pneumatically actuated. So here I can demonstrate the motion of the hand when I'm moving my hand and the motions are repeated. The benefit of this hand is that it can be easily scaled up. So this means we have a same control unit, and a child grows, we can give him bigger and bigger hand. Also, the hand is watertight, so a child can play with water. This is just a demonstrator that we are using here, or it can be also input device for parents who would show the child how it moves. But in practical application, we would apply EMG signals that would read our muscle activity. And when muscle would be activated, then the hand would perform the grasp.
We're looking at removing human workers from hazardous nuclear environments by developing robotic platforms to do tasks that are too difficult for them to do. Right, so we've got here the EPSRC submersible. It's a small underwater vehicle. You can attach neutron detectors, gamma detectors, sonars to characterize unknown and cluttered environments, so nuclear reactors or nuclear storage ponds. What we have here is Corin. It's a hexapod. It's a small version of a bigger version that was planned as a hydraulic system to work underwater in a nuclear environment to cut and manipulate nuclear fuel rods or spent fuel. Motion planning is done with these devices to allow it to kind of brace itself against walls or alleyways to get a decent cut. So I see these being operated at a distance by people, possibly with the help of VR or augmented reality, to be really intuitive, kind of controllable at a very safe distance.
We're looking at robotics, artificial intelligence and autonomous systems for the offshore industry. We're aiming to remove the human from offshore environment, but still have it all controlled from the shore, which is why we look at things like the human-robot interaction, and it's why we need to figure out how robots can work and move around hazardous environments. So here we have the Husky robot here, and that's looking at how robots move around the environment, but also manipulate and interact with the environment as well. Some of the other things that we've been looking at is the sensors and what sensors are required and what data that they need to gather from assets so that we can tell when assets are about to fail, and then also recertify themselves so that there's as little human interaction as possible in that whole mission.
I'm here today representing the SelfRepairing Cities group. We've got a drone here that will be able to print tarmac, so you could imagine a drone flying in, finding a crack. This thing would fly in, be able to print a layer of asphalt over the top, preventing any further damage. We also have the fella down here. This is Magnus. This is a magnetic inspection robot. What it can do is you'd be able to send it into the pipe network. It would be able to locate any very specific areas of damage. So instead of having to dig up a large section of road causing disruption, you only have to dig up the very bit that actually has the damage.
society with robots are pretty much going to be pervasive. Dealing with the aging population as an example, that there will be more retirees than workers by the year of 2050. Robotics economically is very important. How we integrate robots to help us to sustain the economy, and these are the things we need to consider now. To look at not only the hardware, software, but also deployments, policy, and also ethical, legal issues that related to that.